and gentlemen. Let's talk about measurement of angles, shall we? And I think you're already familiar with the degree measure of an angle, but let's consider an angle in standard position in which we have one complete revolution. And if we were to think in terms of the degree measure of angle alpha, what would you like to say that this is equal to? But Doug? 360. Notice the notation that I have used here in that we have this little degree symbol in this raised position. I may also say that the measure of angle is equal to 360 degrees, and we can use either one of these two systems interchangeably. Well, if that's the case, then by a degree, we would mean what? In terms of one revolution, this would be what, Malcolm? 1/360th of a revolution would then be what we mean by 1 degree. In fact, there are two other units of circular measure that we talk about, and another one of them is what we call a minute, and a minute by definition is going to be 1/60th of a degree, and we also talk about a second, in which a second you suspect is going to be what? Well, let's define it as 1/60th of a minute, all right? Of a minute. Now, let's now look at another picture in which we have here two angles that are coterminal. In that here's an angle beta. Notice that we have this in standard position in a counterclockwise direction. And then here's another angle alpha. And notice that these two angles certainly are coterminal. Now, looking at the degree measure of alpha, let's see now. We may think in terms of the degree measure of beta plus 360. Is that right? Or else we may think of the degree measure of alpha as the degree measure of beta plus 2 times 360. Or the degree measure of alpha is equal to the degree measure of beta plus a negative 360. Or, and in fact, I think if we were to try to generalize this, the degree measure of alpha is equal to the degree measure of beta plus, and how then may we generalize this? But plus what? 360 times some number, let's call that number k, where k must belong to what set of numbers? K must be an integer, and this statement is true if and only if what holds true about alpha and beta. Alpha and beta are coterminal, is that right? Are coterminal angles. We have this nice relationship that exists between them. All that this says then is that alpha in degree measure is some multiple of beta, is that right, in a degree measure, where that multiple is 360 times k. Well, we've been working, and I think you're quite familiar with the whole idea of a degree measure, and have been using that perhaps since the 7th grade, or maybe even earlier. There's another unit of measure that I think you are unfamiliar with that I'd like to introduce now, and this is what we call radian measure. Now, what I'd like to do is to look at this circle as we have here, what we call a unit circle, in that the radius of the circle is 1, and the center is at the origin. All right? Now, what I'd like to do is to construct a line perpendicular to the x-axis, passing through 1, 0. And whatever the unit of our circle is, let's take that same unit and simply indicate it on our number line in a positive direction and in a negative direction. All right? Now, what I'd like to do is to think of taking that line and wrapping it around the unit circle, all right, and in which there is no slipping. So that if we were to do so, the number 1 would then come over here somewhere on our circle, and we have here an arc length, all right? In fact, we may even think of this as a directed arc length. And if we then had the number 1 here, its arc length would be some length along here, and at that point then, let's construct this central angle. We'll subtend this central angle. And if this arc length is of length 1, then the central angle, we will say, has a measure of 1 radian. All right? So that, for example, at this point, if we then were to wrap it around the circle, we then would end up at a point here. It would have an arc length of 2 units. The subtended central angle would then be an angle which would measure what? Would be 2 radians. If indeed we took a point, say at pi over 2, and wrapped it around the circle, it then would have an arc length of pi over 2 units. The subtended angle in here, the central angle, would be a measure of what? Pi over 2 radians. If we then consider, for example, the number at pi and wrap this a line around the circle, I think that you would agree that the arc length would come right over here to this point. It would be a length of pi units. What then would be the central angle, thus subtended? It would be an angle of, what, pi radians. Similarly, we may come in a negative direction. If we then were to think in terms of a number -1, and it would then give us a point here on our circle, this arc length, notice now we're calling this a directed arc length, would give us this length here. The subtended angle would be one which is right in here, and that angle would be a measure of what? -1 radians. And I think you can see how we may continue. We may wrap this number line around here 1,000 times, and wherever we end up, we then can think of that angle, in which the angle measure would be an angle in a radian measure. Now, for example, if we then were to wrap around our circle 1 revolution, all right, what then would be the length of that arc? It would be of length 2 pi. Therefore, what would be the angle measured by that in a radian measure? It would be a measure of 2 pi radians. All right? Well, let's now think in terms of that idea, and now let's look again at coterminal angles. Here is some angle beta again, and an angle alpha, such that, now let's think in terms of the radian measure of alpha, and notice our notation is to put a little r up here. It then is going to be equal to the radian measure of beta, and then, let's see, what may we say? Well, in fact, we may go away from beta by some multiple of what? Of 2 pi. So how then may we say that? Plus, let's call it 2k times what? Times pi, where k must be what kind of number? K is going to be an integer, and this statement is true if and only if alpha and beta are what? They again are what? Coterminal angles, okay? Coterminal angles. Well, let's look at another idea. Suppose instead of having a unit circle, that is a circle of radius 1, let's have a radius of r. And again, if we were to think in terms of this arc length, let's call it a number s, all right? And then the radius certainly here is r. And what we now may say is that the radian measure of the angle alpha, as we have it here, is not going to be equal to the length of the arc, but rather you would like to say that it's going to be equal to what? The length of the arc s over the radius of r. So that, in fact, if I then multiply both sides through by the number r, we have the arc length s then is going to be equal to r times the radian measure of the angle alpha. And in fact, I think you'll agree that this is a generalization of what we have just said, because if r were equal to what number? If r were equal to 1, then what would we have but that the arc length s is equal to 1 times what? The radian measure of the subtended angle alpha. Okay? And in fact, that gets us right back here to our unit circle, in which we then have this angle as a radian measure is exactly equal to the length of the arc. All right? Well, let's utilize this more general idea and look at an example in which it says, find the length of arc intercepted by a central angle of 2 pi over 3 radians on a circle of radius 3 units. Okay? Well, let's see now. Our formula that we have just said is what? S is equal to, the arc length is equal to what? The radius r times the what? The measure of angle alpha, call it, in a radian measure. Okay? Now, what then do we know? The central angle has a radian measure of 2 pi over 3, and the radius of the circle is 3 units. Therefore, what is its arc length going to be equal to? And Bill?
2 pi.
Well, all right, well, there we have 3 times 2 pi over 3, which is indeed going to be equal to 2 pi, okay? So that the arc length of the circle of radius 3, in which the angle subtended is an angle of 2 pi over 3 radians, must be of length 2 pi. All right? Well, we've said a few words about degree measure, and now we've been talking about radian measure, and let's see what relationship exists between the two, shall we? And again, let's look at a picture in which we have a unit circle, and if I were to take, say, this arc length of 1 unit of measure, all right, the angle subtended, the central angle, then is going to be 1 radian. That's exactly what we've said. If I then were to, say, take the arc length so that our length were right here, it would be a length of what unit? of pi over 2. Therefore, the central angle would be an angle of what? Pi over 2 radians. If I then were to think in terms of an arc length all the way over to here, it would be of length what? Pi. Therefore, that central angle would have an angle of what? Pi radians. So let's look then at pi radians, and we realize that that certainly is how much of a revolution? It's a half of a revolution. How many degrees then would there be in that half of a revolution but 180 degrees? So there's the key that ties together a radian measure and a degree measure. Pi radians is equal to 180 degrees. Now, if I were then simply to think in terms of 1 radian then, let's simply divide this by pi, and we have 180 degrees divided by pi then must be 1 radian. If you then were to think in terms of 1 degree, let's then divide both sides here by 180, and we'll have pi radians over 180 then must be equal to 1 degree. Okay? Therefore, if we then were to generalize that, the degree measure of some angle alpha must be equal to what? 180 over pi times what? Times the radian measure of that angle alpha. Is that right? And also, we may go the other way, in that the radian measure of an angle alpha must be equal to what? Pi over 180 times what? The degree measure of that angle alpha. Okay? Well, let's look at another example in which we can tie together some of these ideas. Here it says, find the number of degrees of a central angle intercepting an arc 4 pi over 3 units on a circle of radius 2. All right, now the question asks for the number of degrees of that central angle. And our statement that we said in terms of S, the arc length, is equal to what? What's our formula? The arc length is equal to the radius r times the radian measure of the angle subtended. Is that right? Okay. Well, let's see now, what do we know here? We have then the arc length is of length 4 pi over 3. That's a name for S, isn't it? That's 4 pi over 3 is equal to, and now the radius is what? Is 2 times, and here then is the radian measure of the angle that we are going to end up with. Well, therefore, the radian measure of the angle is going to be equal to what number? This is going to be what? Well, it's going to be what? Dividing both sides by 2 here, we have 2 pi over 3. But the original question asked for, find the number of degrees of that central angle. Well, now we have the number of radians of the central angle is 2 pi over 3. Let's then use one of our formulas. The conversion formula tells us that the degree measure of the angle alpha must be equal to what? 180 over pi times the radian measure, which is 2 pi over 3. Well, let's see what that's then equal to. Pi over pi is 1. 3 divides 180, 60, and 60 times 2 then is 120. So the degree measure of the angle is 120. Okay? Well, if a degree measure is 120, what then would be a radian measure, say, of 60 degrees? What would you like to think that is? Of 60 degrees would be what? 2 pi over 6. 2 pi over 6, which is pi over 3. Suppose, for example, the radian measure were pi over 6. What then would be the degree measure of that angle? 30 degrees. Suppose we had an angle of, say, 90 degrees in degree measure. What would be its angle in radian measure?
Pi over 2.
Pi over 2. Suppose you had an angle of, say, pi over 4 radians. What is its degree measure? 45 degrees. And in fact, this being able to go back and forth from a degree measure to a radian measure is going to become very important to you. Okay? Let me give you your homework assignment, and you may think about some of these ideas.